Welcome to another video on Thevenin's theorem. We are required to find the Thevenin equivalent of this circuit across the terminals A and B. And to do that, we first have to know about the currents in the circuit. And now, to do that, we could just use mesh analysis. We have three meshes here, one super mesh, and the current of this mesh is already known. We know that it is 2Ix. Since there is a current source, so the current here is 2Ix. No need to stress ourselves over that. And then one super mesh. Let's call this current I1. Let's call this current I2. And we know that I1 minus I2 is equals to 4 amperes. I1 minus I2 is equals to 4 amperes. We can call that our first equation, equation 1. Also note that this is the current Ix over here that we will be using for the dependent source. This is Ix. The next thing we want to note is that I2 minus 2Ix, I2 minus 2Ix is equals to Ix. So we know that I2 is equals to 3Ix, and call this a second equation. We can then proceed to write in a supermesh equation here, and say I1, okay, minus 12 minus plus Ix plus I1 minus 2Ix, I1 minus 2Ix equals 0. Now we know that 2I1 minus Ix equals 12. We can call this our third equation. Solving these equations simultaneously, I1 is equals to 32 over 5. I2 is equals to 12 over 5, and Ix is equals to 4 over 5. The next thing to do would be to connect a voltage source across these terminals, and that will be your Vth, and then you can then write a KVL equation in this loop, and so it will go like this. So we have 2Ix minus I1, that will be 8 over 5. 8 over 5 minus 32 over 5 plus Vth minus 6 equals 0, and with that we have that Vth is equals to 54 over 5. Now the next thing to do is to find Rth, and due to the presence of this dependent voltage source, what we are going to be doing is we are going to be turning off all the independent power source. Then we're going to plug in a 1 volt power source here, calculate the current, and the inverse of the current, it would be the Rth. So this is what the circuit is going to be like after we put off all the independent power sources. And what we're going to do next is we're going to connect a test voltage across these terminals, the open circuit terminals. So this is our test voltage right here, and it's going to be a test voltage of 1 volt. So now what we're interested in finding is the current I coming out of this power source. You can easily determine the value of the current I using mesh analysis. If we call this our first mesh, this is our second mesh, and this is our third mesh, then what you know is that the current I would be I3 minus I2. I3 minus I2. So we're interested in finding I3 minus I2. First things first, we know that we know Ix is flowing here. We know that I3 is equals to 2Ix. Okay, and we know that I1 minus 2Ix is equals to I1 minus 2Ix is equals to Ix. From this here, then we can say that I1 equals 3Ix. We can call this our first equation, and this our second equation. These three equations can be solved simultaneously. With this, we know that I1 is minus 0.5, I2 is minus 1.75, and I3 is minus 0.25. We're interested in finding I3 minus I2. This should be Ix. So that means that I3 would be 1. I mean 2Ix, yeah, minus 1. I3 would be minus 1. I3 would be minus 0.5. Minus 0.5. With that, I would be equals to minus 0.5 minus 1.75, which would be equals to 1.25 amperes. So RTH would be equals to 1 over 1.25, which is equals to 4 over 5, I guess. Yeah, 4 over 5 ohms. For this reason, the equivalent resistance the equivalent Thevenin circuit will look something like this. We have a resistor, we have A and we have B, and we have 54 over 5 volts, and we have 4 over 5 ohms. Thank you for watching. Don't forget to hit the like button and subscribe. See you later. Bye.